to Raoul-Gabriel Urma.
Oh. How's everyone feeling? Good? I can't, we can do much better. How are we feeling? Good? Yes. Awesome, awesome. So, I'm going to pick on someone. What's your name?
Peter.
Peter. Peter's going to be our best friend today. So, Peter, here's the scenario. You're having a dinner with some clients and your boss, right? And you need to sound really smart. What do you do? What's the trick? What do you do in that situation?
Sounding smart in the boss?
You need to look good in front of your boss and the clients. Don't worry, I've got your back. You're going to be able to say Spark, Big Data, Hadoop, Amazon EMR. Instantly, you're going to sound really smart. So that's what we're going to do in this talk. So it's really, really buzzword compliant. So IBM, a big company, has made a lot of money thanks to the marketing department. Big data. So you know what? I think big data is not cool enough. We need to go next level. A lot of people use AI to kind of make things a bit more sexy these days. Let's go for humongous data, because that's the next cool thing. So in this talk, it's all about humongous data. But maybe just before we start this talk, just so you get an overview of what's going to happen. So I appreciate there's different interests in this room, different backgrounds and levels. So in the first part of the talk, just want to provide you an idea of what's available in the big data kind of ecosystem. In the second part, we'll get hands-on. So I'll be typing some Python code. So no Java here, just Python code. And then I'll show you a little bit how you can extend your code so it works on a cluster of machines. So what's the first big data system? Any ideas? Peter, what do you think is the... Sorry, I'm going to pick on you, Peter. What do you think is the first big data system? There's no right or wrong answer. What's your thoughts on this? No clue? So, relational databases? Well, interesting. So, when you don't know the answer for a question, where do you go? Google? I went on Wikipedia, which is kind of quite close. And what Wikipedia told me is that it's the Library of Alexandria, from the great Alexander. So it could store about 400,000 papyrus scroll. So if you do a bit of math, so papyrus scroll is about 20 pages, has 500 words per page. If you multiply all that stuff, you get something between 4 gigabyte and 40 gigabyte of data across 60,000 square meters. So it's probably the first system where you could structure data and really access it, but in a really, really slow manner. So that's sort of fun fact. So what's big data? Vin Diesel, he brought us triple X. Today is going to bring us triple V, the triple V of big data, volume, velocity, and variety. So what all that nonsense means. So volume is really the idea that I've got a large amount of information. So Peter, do you use Facebook?
Yes.
How frequently do you go on Facebook?
Once an hour.
Once an hour? Do you enjoy taking a cheeky selfie now and then? Yeah? Come on. It's a safe environment. There's no problem. So let's take a look at Facebook, right? It's got about 1 billion users. I think these days they've said even 1.7 billion, so it's pretty crazy. So let's say our average daily contribution is about 1 megabyte. So, like a photo, a selfie, maybe you like some stuff around. That quickly adds up to quite an important amount of data. So 365 petabyte of data per year. And that's not even including things like replication and backup of this data. That's what volume is concerned with. You have a ton of information. And that leaves with some problems. How do you store petabytes of data on one machine? Now, the general idea is maybe we can share some data across different machines. So maybe Peter and I, we're going to share some data, right? But that comes with problem. Who decides how we distribute the data? Who's going to process which elements? We need a sort of coordination mechanism. Now, I don't know, maybe Peter went for a big night out, he's really hungover, he's down. What do I do, right? So fault tolerance and distribution is the topics that are really important with volume. So that's one of the challenges that defines big data. The other one is the idea of velocity. So let's say, Peter again is having a good day. He's like, Raoul, I've got a ton of work for you, firing stuff at me. And suddenly I get all this information that I need to be able to process. So that's the aspect that the data is in motion. So CERN, any physics geeks in the room? Yeah? No? Yes, there's always one. Always one. They've published some results, and they're saying, about 10 gigabytes of data every second to keep track of the particles collision. So that's quite interesting. Twitter, again, if you're a fan of selfies, there's about 3,000 selfies per second that are shared on Twitter. So this leads to some interesting problems and challenges from an architectural point of view. Because on the one side, you've got producers that are firing information at you, and the other side, you've got the consumers. So if you've got a single consumer, a lot of producers, then I'm not going to be able to cope with the work. So suddenly, we need to start and distribute those things as well to cope with the information coming in. Okay? So that's another characteristic of big data. And the final one is variety. All right, guys, let's be honest. It's a safe environment, don't worry. Who likes a little bit of Excel spreadsheets now and then? Yeah? Oh, we love it. I knew it. So the great thing about Excel spreadsheets, besides they crash quite often on a Windows machine, is that it has a very common sort of columns and rows kind of model, right? So it's really easy for us to think about a table, update, and find things, okay? So relational database, I think a gentleman over there mentioned relational databases, are really based on this idea that you've got rows, everything fits in a table, conceptually is really simple to work with. However, not all data fits in this two-dimensional table. So let's think about a payroll system. Who here works for a company that has a global presence, maybe offices in UK and all over the world? Raise your hand. Right. So how do you model a payroll system for a global company? That's quite a tricky challenge, right? Because in UK, you'll have different schemes, the PAYE schemes, the contractor schemes, the limited companies, and different tax. In Japan, it's probably completely different. In the US, it's probably completely different as well. So how do you come up with a unified model for that? It's really impossible, right? And what if requirements are changing? What if there's a new election coming at some point and things are changing? That's something to keep in mind. Things like graph structure. So if you think about Facebook, your friend, we're all friends of Peter. He's the most connected person. How do you model this kind of relationship? That doesn't fit really nicely in a two-dimensional table. So that's a lot of challenges that you get with data in general. And that's the third characteristic, variety. Now, this is where things are really interesting. This is a landscape of big data systems and technologies available. Doesn't that look a bit scary? But there's the good news. If you're a big data consultant, you can make a ton of money because no one understands it. So that's always good. So what I want to do now is to really provide a different classification to this problem of what are the big data problems. I'm going to classify them into batch processing and stream processing. So here's examples of what batch processing is. So let's say on a monthly basis, you need to calculate your payroll. So how you're going to pay the employees. So you've got all the data of the employees, and you need to process the data and provide some results. So that's kind of a monthly job. If you do a bit of machine learning, you want to train some classifier. Again, you've got this data here. It's at rest. It's available. You process it, and that's how you train your model. Okay? So who here works for a bank in London? Any? Right. What's your name? Satya. Yeah. Do you enjoy compliance and regulations? No. No one does. But it's an important aspect of running a competitive bank. You've got to fit with regulatory reports. So another batch processing example is we get all those trades, and on a monthly basis, we need to issue reports that we're going to provide to the regulators. Okay? So that's how batch processing looks. The data is available at rest in some sort of storage. You want to make use of all the resources available in the best way possible to process it. So that's batch processing. And then you provide a result. Okay? Now the alternative, and it's not an exhaustive list, this is another category available, is stream processing. And that's the idea that in real time, you need to provide an answer. So maybe Peter, our best friend here, sends me an email. You need to figure out in real time whether it's a spam or not, okay? So another example of that, which has more of a business impact, is fraud detection. Someone pays for something, we need to be able to tell whether that transaction is fraudulent or not. So that's a real-time concern, okay? So here's a beautiful diagram that explains this for those of you that are visual. So the data is in motion, it's streamed, and you need to provide an answer now. Okay, so it's not in rest, it's in motion. So the idea is that you're concerned with low latency. Whereas batch processing, you don't really care about the latency. What you care about is making good use of resources available to process the information. Let's have a quick quiz to see how everyone is doing. All right, and I've got a free beer voucher for those of you that can get it right. So, generating a balance sheet from all the invoices in a month. Is that batch processing or is that stream processing? Awesome, awesome. That's great. Data is at rest, process it. What about the second one? Real-time alerts. Yes. And the third one? PageRank metrics. Batch. So this one is kind of a weird one because in ideal scenario, you'd like to be able to recompute the PageRank of a web page in real time. In practice, it's impossible. So it's a batch processing job because the sheer amount of data available on the internet can't be processed in real time. So great, it's batch. And the final one? You guys are awesome. Best audience ever. Yes, the sponsor of this conference are going to provide freebies for everybody. If they don't, they are responsible, okay? Fantastic. So we get an idea of what big data is, characteristics, some different kind of business problem associated with big data. So how do we actually make it work now? A single machine is too slow to process the information. So what do we do? More power, all right? Let's go big. Let's scale up. All right, that's one possibility. And usually it's the best possibility. If you can have a machine that has more performance, that's great because the same program is going to run on that one machine. So that's always the easiest option, okay? So I can't recommend this more. You don't need to go distributed if you can still run your thing on one machine. It's going to be easier. Now, the other alternative is, well, if you don't have the, if you can't get a bigger machine because maybe it's more expensive or maybe it's actually not good enough, you can always scale out. So you can get different machines and then you have to coordinate. So Peter and Siva, I think we're all going to partner up, and kind of distribute the work. That's what scaling out is. But nothing comes for free, right? There's pros and cons for all of this different approach. The great thing about scaling up is that your program that's running one machine is still going to work on one machine, right? It's the same programming model. But the downsides are that it might be really expensive, and usually you have a diminishing return when you try to kind of get more and more CPU and memory on the same machine. And you also have a single point of failure. If Peter had a big night out and he's down, I can't call him. So game over, all right? However, scaling out, it's kind of the reverse properties that we get. It's more difficult to use. So your Java, your Python program, suddenly you can't just run it because there's multiple machines, right? So you're going to have to split the work and decide who does what and combine the work. So it's more difficult to interact with. But you get great benefits. It's usually cheaper, so you can get some kind of medium-sized computers that are really cheap and get them to work together. It's flexible. You can scale out and adapt to the demand, but you also can scale down, if we have less work to do. And a typical example of that is, World Cup final, of Trump is tweeting, Twitter goes crazy. But if there's nothing that happens, then the velocity of the information is low as well, okay? And that's also fault tolerant, because if a machine goes down, you still have others that can coordinate each other. So how does that work from a technological point of view? And this is where Hadoop comes in. And Hadoop is really an ecosystem that provides solutions for distributed work and distributed processing. So usually what you need if you want to do some work is one is a file system, where you can store information, you can read information, and that's called HDFS, which stands for the Hadoop file system. So essentially a distributed file system, bunch of machines here, and I want to read information, it's stored on one machine, on the others, but the file system abstracts that for us. So that's great. The other thing you need is something like an operating system, right, that's able to manage the resources available. The memory available in the cluster, the CPU available, and that's called Yarn, okay? Now on top of that, we need a way to be able to specify a query. that's going to be distributed on this cluster. There's a range of technologies available. In the past, people would use Hadoop MapReduce. It's pretty old school now, contains two operations, map and reduce, so it's quite hard to describe business problems in a declarative manner because you have quite a low-level API. Now, the good news, there's something better now called Apache Spark, which is also implemented in a more efficient manner in comparison to MapReduce. And all that does is to provide you with an API to specify different queries, and we'll look at some example, and it's run on your cluster of machines, okay? So that's pretty cool. Awesome. So, a bit of live coding now. Fantastic. A bit of live coding is always fun. So, what I want to do here is to show you how you can process some file using Spark, and then suddenly the file is going to be too big for my little MacBook here, and we're going to have to set up a cluster of machines. Okay, so that's what we're going to do. I've got something called Zeppelin. It's a bit like a Python notebook, but has different features, supports different interpreters, and generates graphs and previsualizations out of the box. So, 1 plus 2, I'm sure everyone wants to find out what's the answer. So you get 3. So it's a bit like a REPL. You type some code and you immediately get the result. So what we're going to do here is to look at a file called olcdump. So it's a JSON file. So JSON, quite a popular format for information. It's human readable. So I can see here, there's different attributes, the title, the name of a book here, etc., etc. Okay? So this data set I've got here is a sample of the Open Library data set. So you can download it from the internet, bunch of books, the authors, location, etc. And that's what we're going to be processing. Okay? Sweet. So the first thing you can do here in this nice environment is to make use of Spark and to say, well, you know what? I've got a, can everyone see here? It's big enough at the back. Can you see? Yep, great. So we've got this file here. Now I want to load up. So we're going to call this the raw data. Okay? Fantastic. Now, if I inspect this variable, you'll see that it's some sort of a Sparky text file called an RDD, Resilient Data Structure. So next thing we might wish to do is to find out, well, how many lines are there in this file? So you can say that count, and that's going to provide the answer immediately. It's about 140,000 lines. Okay? Pretty cool. Now, if I inspect what's inside that file, let's take the first line. What we'll see here is that we've got a string, and this string is a JSON data structure. Okay? So it's not super useful because I've got a string here. I can't really access the properties, things like, hold on, the effect of differentiated marking tools and motivational treatment on figural creativity. Definitely want to read this book. But what we'll want to do here is to be able to manipulate the string as if it's a Python object, so I can extract the information from it. So what I can do is import JSON. What I'm going to say is JSON.loads here. Take the data and tell me what the first element here. And you can see now we've got a Python object that is returned. So I could say here the first entry, right? And if I say first entry and then extract me the title, we get the title. Okay? Fantastic. So what I'd like to do here is to kind of figure out different queries on this data set. Okay? I'd like to find out what kind of keys have we got in this data, what are all the titles. So first step here is going to be to convert the raw data into a Python object. So map is an operation available in Spark. And what that's going to do is to apply this function here, JSON.loads, on each entry available. Okay? So each line in my file is going to be converted to a Python object. Beautiful. So we're going to call this my JSON RDD. Fantastic. And what I might want to find out here, if I say, give me the count again, hopefully we is not defined. So let's JSON, beautiful. I love you guys. You guys are the best pair programmers here in the house. Beautiful. and we get the same answer as before, right? Because nothing changed, the same number of elements are available. Fantastic. Now, maybe what I want to find out now is, if I get my JSON RDD, I'd like to find out all the titles that have Cambridge in the title, okay? So we're going to create a little function here, entry. We want to find out if the attribute title is actually available. And then we want to find out if Cambridge is in the N3 and the title, okay? So let's do a little count on this. Fantastic. Apparently there's 76 books that have got Cambridge in the title. Great. So filter is another useful operation available in Spark. Applies its predicate and filters out the elements. So what's really beautiful here, if you start noticing, is that we've decoupled ourselves from the execution model, right? We've got this nice operation map, count, filter. I don't care whether it's going to run on one machine, whether it's going to run on a cluster of machines. That's all abstracted away through this API. Okay, so we've got a nice decoupling between the query here and how it's actually implemented under the hood. So let's inspect this a little bit. There's another little nice operations available called take, and that's going to return me the first 10 elements here in this data set. And we can see here, all those JSON entries. Now that's a little bit ugly. What we really want to find out is all the titles. So we're going to call our friend map again. We're going to say, well, just give me the titles and take 10 of that, okay? So if we run this from here, with a bit of luck, we get all those beautiful books with Cambridge in there. Apparently there's a lot of English courses available. Surprise. All right, so hopefully that gives you a little idea of how the API works. Now let's try and do some more interesting things. We've got this data set here that has JSON entries. But data in general is not always perfect. There's always missing entries. Some data has some attributes. Some data doesn't have the same attributes. So let's try and get a feel for what the attributes available in this data set. So another operation available is called Flatmap. And what we're going to get here is all the keys available in one entry. Okay? Now, I could have used map. Okay, so we're just going to apply a function on each element here. But what you'd get is an array of all the keys. What Flatmap is going to do is to flatten all those intermediate arrays. Then we can call distinct. It's going to remove duplicates, and then I can count that. Okay? So I forgot my lambda here. Awesome. So what we find out here is that there's 77 unique entries available in the data set. But hold on, when I was doing it first here, I'm pretty sure there isn't 77 keys here, right? So if I do a keys here, what you'll see is that there's actually a limited size. And if I find the exact number, see there's only 22. So that's interesting, right? The first entry doesn't contain all of the keys. So what we can do here, I could call collect. What that's going to do is to take this RDD, so this Spark kind of list, and convert that into a Python list. So if we collect here, what you'll see is there's quite a lot of interesting attributes available. Okay? So what I really want to do now is, well, what's the distribution of the keys available? Is the average kind of a 20, or is it more kind of 70? For each entry, I'd like to build a graph that tells me the distribution of the number of keys. Okay, so that's quite an interesting problem here to solve. So how do we do this in Spark? Right, so what I want to do here is to build kind of a count per key. So for each key, for example, title, I want to find out how many entries in my data set have the title attribute. Okay, how many entries in my data set have the attribute revision? That's the problem that I'd like to specify. Okay, we'll get our JSON RDD. Now we can call map, and just bear with me here for a little second. What we're going to build here, and that's one of the things with Spark, you really have to follow this kind of a principles of producing outputs that you can then combine together. So what we're going to do here is to find out for a given entry, I'm going to build a tuple, that tuple is going to say, well, how many keys have we got? Okay, and then we're just going to give it a count. Okay, so what that's going to do is to say, well, for example, the first entry, there is 22 keys. Okay, so 22 appears once. All right, we're going to do that for each entry, and then what we're going to have to do for each key, for example, if 22 has happened multiple times, we just need to combine all the ones. If we sum them up, that gives you the number of times you've got a certain number of keys. Okay, so there's another operation here called reduce by key. It's going to take a lambda, and really what we want to do here is to say add up all those ones. So that's the x and the y here, and that's the count per key. So if we collect this stuff, we're done. And now let's take a look at what count per key looks like. Fantastic. What you'll see is, there's 6,976 entries that have 25 keys. All right? Now, what do we do with this? So this Zeppelin notebook here has support for some interesting visualizations out of the box. So for entry in count per key, what I'd like to do here is to print that stuff. So we're going to tab it up. So that's just some Python syntax here just to format things around a little bit. There we go. The first entry, blah, blah, blah. If we run this, what you'll see is that the Zeppelin here is providing us with a nice little table of occurrences. So that's pretty, but you get more interesting things, like if you want a graph here, which is not super nice, but well, let's go for this beautiful, colorful pie chart. Right? Kind of gives me an understanding of the information. So, if I click on other stuff here, kind of get an idea of what the distribution is. So it's definitely skewed more on the 20 side rather than the 70 side, okay? So that's what you get out of the box with Zeppelin. Awesome. So that was the second part of the talk. So what I wanted to do really here is to introduce Spark as a tool to do data processing. But the win that you get is that you decouple from the execution model. Now, how do we take this from one machine to a cluster of machines? How do we go big data? Okay. So for this, I'm going to introduce AWS EMR. So what it is, so Amazon is making so much money with the whole cloud stuff. But EMR is another thing that's quite useful to bring up during fancy dinner parties. It means elastic map radius. Okay. So what's really good about this is that it configures for you a cluster of machine with Spark, Zeppelin, and other kind of technologies out of the box. So, one of the bane of software development is setup, right? We all hate setting up stuff. Amazon does it for us, which is nice. So we can focus on the fun stuff. So what you can do is to go to AWS, and what you'll see is a bunch of different services available for different concerns. So if you want to have a little machine set up in the cloud, you've got EC2 that can do that. So here's the Cambridge Spark AWS dashboard. So please don't tweet this stuff. But you can see we've got 19 running instances. Okay. S3 is another service that lets you store files on the cloud, and then you can kind of download it and query it. So what you'll see here is that I've stored a file called the OLCDOM, but this time it's 92 gigabytes. Okay, so it's not whatever this one was, a few megabytes. We've got now 92 gigabytes. So that's a more interesting problem. You've just suddenly handed over this JSON file. Hey, can you just run kind of a couple of ad hoc queries? Let's solve the problem. So that's what we want to do. So the tool that I'm going to use is called EMR. It's right here. And what that does is, beautiful names. You can create a cluster. You give it a nice, interesting name, like we love Peter, all right? Everyone needs to buy him a beer. Everyone needs to buy him a beer. And then you can set up your stack. So maybe you want Spark, Yarn, Ganglia, which is a monitoring tool, which I'll talk about in a second, and Zeppelin, that Python notebook that I was using. You can choose between different kinds of machine. So here an M3X large, 16 gigabyte of RAM, and the number of instances that you want. You know, you could go 9,000, it's probably not going to work, but something like 16. You can set up an EC2 key pair. So if you want to SSH on any of those machines, you're going to need a key. And then you create your cluster. When you press that button, under the hood, AWS is going to spin off a bunch of EC2 instances, set up into a cluster, and give you a master access. Okay? That's going to take a few minutes. And before the talk, I set that up already, because you know the god of demos, and I don't want to wait for a few minutes. And you can see you've got a bunch of things available. One is something called Ganglia. And what Ganglia gives you is a monitoring dashboard for the resources in your cluster. How much memory is used, how much CPU is used, any kind of stuff. So you can see here we had a little peak. So at 12:50, I set up the cluster and I tried a query just to check everything's working. So you can see there was a bit of activity at that point in time. Okay, and this is the memory usage. I've got a 140 gigabyte of data here being used because I cached some data in each of these machines. Okay, so that's Ganglia, which is pretty useful. And the other thing you've got is the Zeppelin notebook. So if I go to EMR, you'll see there's a link here. So I can click on Zeppelin here, and that's going to bring up the dashboard. And what I did is essentially load up my file from S3, so the 92 gigabyte file. I converted each entry to Python object in JSON, and now I wanted to count how many there are. Right? So if I run this query, what you'll see is that the job is going to get started off in Spark. Yarn is going to manage how to schedule that stuff on the different machines. So that's going to go and do some work. So let's wait a couple of seconds and see what happens here. And in the meantime, with a bit of luck, if we go back to Ganglia, what we'll see soon enough is that some activity, you can see it's kind of starting a little bit here. We'll see that some activity is starting to run. So the job is being computed. And if I go to Ganglia and refresh, we'll see that the spike is coming in, obviously, you know, CPU usage. We're trying to get all this data, we're trying to convert it, and then we're trying to aggregate all that stuff. So that's quite CPU intense. So we're not going to run through the whole thing, but that's going to take usually 2 to 3 minutes because there's no indexing, right? So we've got the raw data here, we need to process it. So that's kind of the scenario where here's a big JSON file, maybe some logs that you need to throw away, run some ad hoc query, and then dump it somewhere. Perfect tool to use here. So that's being processed. Okay? Awesome. So I think that's all I wanted to say on EMR. So we're going to let this one go off and run, and let's see at the end of the talk what the answer is. So everyone doing good so far? Awesome. So what else have I got to talk about? So yeah, EMR. So the beauty, as you can see, is really beautiful, right? Because we've got a Spark API, and I can run the same queries that I was running locally. So maybe, you know, you're doing some job at work, you've got a sample of data, you kind of iterate through your stuff, and then you want to run it in a cluster. Same code runs in a Zeppelin notebook, right? So from a migration point of view, it's great. Spark is really interesting because from an integration point of view, it supports Python, Scala, and Java. And usually those are programming languages that are used by companies for production work. So if you're already using those programming languages, the conceptual migration to Spark is really low because it's the same kind of programming language that is used. So that's always a benefit. I've done the demo, and I've done this conclusion. Awesome. So a little plug before we look at how many entries have we got in this open library data set. So Cambridge Spark, what we do is professional development for data scientists and developers. So we run different courses, and if you're interested in learning about data science techniques and machine learning, we also have a course on big data analytics if you want to learn about both batch processing, also stream processing, so things like using Kafka, using Kafka streams or Spark streaming. If you're interested about big data file formats, things like columnar storage, which often are going to give you more of a performance wins in comparison to just loading up something from a JSON file, right? Because there's quite a few clever things that you can do, including indexing, so that's quite interesting. And also quite cool, we have a 6-month program to really help you transition to become a data scientist. It's a part-time program running over weekends, so it's non-disruptive. You can still work during the week. And we've got our in-person classes running in London. So check that out. And we have a data science summit happening in Cambridge. Who else live 20 miles from Cambridge in the room? Right. So I need to sell Cambridge to you really quickly. Lots of history, pretty colleges, good food. If you've got a family and the kids, you can go for a weekend in Cambridge. It's very nice. But we've got this conference running the Sanger Institute, which is the largest genomics research center in Europe. So that's pretty cool. All right. So let's see how we're doing here. Still running, 4 minutes. All right. I'm afraid we're going to have to keep it running, but trust me, it works. And if you want to follow, if you want to try the code samples that I've run through today, if you go on our website, cambridgespark.com, you'll see that we've got different tutorials here available on different topics, so you can go enough and do that. And all the code examples and explanations available in these tutorials, including how to set up EMR and this kind of stuff. So just check it out, and you can have a recap at home. Cool. So thanks for coming. The price. Yes. The price. Oh, EC2 pricing. So I was using an M3X large machine that cost about 20 cents per hour. Apparently the Amazon EMR price is even lower. So 7 cents per hour. I had a cluster of 16 machines. All right, so if we run it up, it's going to be like £2 for an hour for 16 kind of machines. So it's pretty affordable stuff. Does that answer your question? No. Attending the summit. Great question. So if you go to the website here, you can register, and you'll see it's £99 for the conference day, but the early bird ends tomorrow. So you can grab your tickets fast. So £99, pretty affordable, and you get a nice trip to Cambridge at the same time. Okay? We've got some cool speakers lined up. People from the Alan Turing Institute, from Oxford, Cambridge, and also industry, including the head of quantitative biology at AstraZeneca. Raoul-Gabriel Labs is also represented there. We'll announce some new speakers next week. So ARM, big company in Cambridge, is going to talk about how deep learning is influencing the hardware innovation. So that's also going to be really cool stuff. And David Stilwell, really interesting guy, is a lecturer at the Judge Business School. So apparently the Trump campaign, they did a lot of analysis on social media, so they could target people that had different interests. And by targeting those specific individuals, they could kind of subliminally encourage them to vote for Trump. And apparently it works really well. And his research was actually used by a company to do just that. Pretty scary. But he's going to talk about how his research was used, and he's not too happy about it. It's all about analyzing data from social media to impact the world. So yeah, cool. Awesome. So I'm just going to put a slide up here. Any other question? So we've got, are the courses online or not? So we've got courses running in London on most weekends, and we also have courses running in Cambridge. We run courses for companies as well as in-house training. And online courses are coming in the next few months. Cool. All right, guys, if you want to talk to me, I'll be at the coffee break. It'll be great to meet some of you and have a chat and get some beer. And have a round of applause for Peter here. Thanks, Peter.
Okay, thank you very much. As you said, we got the coffee break next. And a big thank you to him. Big thank you to Raoul. Thanks.